Alright, so I'm going to hit this. Hopefully it will take me like 10 minutes long to finish this feature, or this class right here. We talked about linear graphs, we talked about quadratics, we talked about cubic, we talked about moving these things around, the square root function, the cube root, the rational. Did we talk about the rational? I don't know. I don't know if we did. Let's try it. The rational looks like this. Okay. Here's the thing about the rational function. It's very interesting. It looks like you got a 1 over x, and that's y equals 2. So, just kind of thinking about, you cannot see me. Can everyone else see me? Can you guys see my face? I hate to say it, Erica, but if everyone else can see me, then you're going to have to log out and log back in, because that might be a problem on your side, not mine. I apologize. I really wish I could fix those. Alright, so it looks like you guys can see my face. Let's talk about this y equals 1 over x kind of deal. Okay? As x gets really, really big, alright, so let's start off with, what if x were equal to 1? If x equals to 1, what does y equal to? Come on, say it. Don't be shy. 1. Very good. Yeah, because 1 over 1 is still 1. If x gets really, really big, then what's going to happen to this y value is this denominator is going to get really, really big, and so your overall value is going to get really, really small. So it's going to kind of taper off, and it's going to get closer and closer and closer to the 0, to y equals 0. You'll never actually reach y equals 0 because you can make x really, really, really big. And yes, it will be a really, 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 really small number, but it won't actually be 0. I guess the idea is maybe you can make x infinity and then y equals to 0, but then again, there's no such number as infinity. It's just kind of this idea of someplace you approach. So yeah, as this thing goes infinitely far that way, this thing gets infinitely close to 0. I guess you could say that. Now, as x gets to be a fraction, let's say it's between 0 and 1. As we let x get closer and closer to 0, let's pretend that x is equal to 1/2. Then what happens? Well, y equals to 1 over 1/2, giving me 1 times 2 over 1, because you take the fraction on the bottom, you flip them over, you multiply, so you end up getting equals to 2. Does that make sense? Agreed? So at the halfway point, I'm going to reach 2. I guess 2 would be more up here. And then at the quarter point, I would reach 4, so up here. And at the 1/8 point, I'd reach 1/8 up here, or 8, right? And what about making this a really, really, really small number? Like, I don't know, 1 over a million. X equals 1 over a million. How far up am I going to be? Y equals to what? A million, right? Because 1 over a million is just a million. So this thing is going to go and skyrocket up. Now can x, I'm making x be really, really small. A millionth of something, or a billionth of something. Can I ever let x equal to 0? The question is, can you ever have a 0 in the denominator? And the answer is no. You can't have a 0 in the denominator, so what we have here is this thing called an asymptote. I know. But it's not spelled the way your mind is thinking, with 2 S's. It's called asymptote. And it means it's a line that approaches but never touches. So it goes up to infinity as you get close to 0. Same deal here is you can think about the negative side, and I'll just let you kind of think about that, but that's kind of how the graph will look like. It's going to be, it's not really symmetric. This graph isn't symmetric. Like, I can't take this graph and then just like stamp him on the other side and then boom, he becomes that. It's kind of like a double snap, right? Like you take this, stamp it over here, and then you fold it down. And that's how you get that graph. So it's symmetric. Really, it's symmetric about this diagonal line. Like if I were to If I were to take paint and I were to paint this over here and then I fold this as a piece of paper, it would make exactly that. Does that make sense to you? Are we cool with that? This is the rational function. I'm just kind of telling you guys things about it. All right. I have a question for you, just curious to know. Y equals 1 over x plus 3. What would that do to the graph? I'm just wondering if you guys can think about how that would affect the graph. I'll give you a hint. Yes, exactly. It would move it up by 3. Very good. And also, if I did that, what would that do? No, no. I'm going to move down. Erica, I don't know if you can still see the camera, but I'm giving you a hint. Yeah, exactly. It's going to be going, well, no, actually it'd be going to the right. Because the -3, remember that the minus, when moving to the right and left, it does the opposite of what you would think it would do. Yeah, it would move to the right, 3 units. There we go. Right. I was actually pointing to the right, even though, I don't know, does that seem like the left to you or the right? I can't tell with the computer being reversed and everything. Yeah, it's the opposite of that Beyonce song. All right, I'm going to erase this. I'm going to move on. I have like 5 more minutes. I want to cover one last thing, piece of information, and it's called the piecewise function. Piecewise function is actually really straightforward, but it's funny when you see it, and that's why I wanted to cover it. Oh, I talked about the absolute value once. That one we did. Piecewise function. Here's what the piecewise function does. All right. The piecewise function is kind of like no. I'm not going to finish off. I'm just trying. What I'm really trying to do is I'm trying to condense all of my lectures to a half an hour. So I feel like I have to go through this really quickly. I'll spend more time with you. I'll spend the full 40 minutes. But I'm really trying to get everything I want to say in half an hour. So here's what a piecewise function looks like. All right, this would be a good one. I guess when I taught you guys the concept of an absolute value function, one way you can kind of think about it is you can think about it as a piecewise function. Let me show you what a piecewise function is right off the bat. All right, here we go. This is a good piecewise function. Here's what a piecewise function is. F of x equals 1 minus x, x squared. And then they have the if x is less than 1, if x is greater than or equal to 1. So the way you graph that is you would graph both of those. This is not hard to graph. The x squared, that's just a parabola. Got it? I'm going to make it a dotted parabola, dotted line. We cool? And then this right here is not even that hard to graph either. This is a straight line. This is y equals mx plus b. M being -1, b being 1. So it crosses at 1 and it goes down -1. So it goes down this way. I'm going to make that a dotted line as well. So all this graph is saying is that when you are standing at x is smaller than +1, so here's the x value of +1, then you want to use this graph, the line one. See? That's the one that's attributed to that domain. As I told you, the domain is the allowed x values. So it's saying, if your x values are less than 1, then use this line. So I'm going to solid that guy out. In fact, what I'll do is I'll probably erase the parabola just so it won't confuse you. If your domain is bigger than 1, so if I'm standing on this side, then I'm not going to use this straight line. I'm actually going to use the parabola as my graph. Does that make sense? Now, there's a little blurb about dots, and that would be like at these endpoints. Just think of them as like it could be here and it could be here, but which is it? Because it can't be both, right? If it's both, it won't pass the vertical line test. It won't be a function anymore. So it has to be one or the other. Which one do I make solid and which one do I leave open? Well, you look at over here, and this says, yes, and at x specifically equal to being 1, you still use this graph. So I'm going to put a solid dot over here, but over here, I'm going to put, this is only valued for when x is less than 1, but not exactly at equal to 1, so I'm going to put an open dot right there. Does this make sense to you? Do you understand a piecewise function now? Awesome. I have a question, just curious to know, did you understand a piecewise function before? If I threw this up there, could you draw for me this graph? Not at all. Oh, okay. Well, a piecewise function is, I think it's pretty easy. All you got to do, I mean, it's not even twice as hard. It's just, you got to do the same problem twice. So, you just, I mean, you look at this graph, and that's the equation of a line. You look at this graph, and that's the equation of a parabola. And then all you got to do is just adjust as to where those equations come into play. All right, I'm going to erase this. And I'll tell you what, because you guys said that you guys probably wouldn't have understood this to begin with, I'm going to do another one just for you. Let's just try this one, okay? And I'm going to just do it real quick. I'm going to warn you, this one's going to be quick because I want to hit the chapter 6 stuff, which is what I probably should have been working on last week, and I don't have time because I'm trying to do these half-hour lectures, and they really put me up against the wall. But let's go. F of x equals a big parentheses negative 2x minus 4, x squared minus 2, and the number 3 if x is less than negative 3, if, I'm going to write this second if like this, if x is in between negative 3 and 2, and also if x is bigger than 2. So if I were to graph that, all right, let's try this. 1, 2, 3. I'm going to go backwards 3. On this side of this side of this graph, I'm going to draw this line right here. So that would be a slope of negative 2 crossing at negative 4. So it would be 1, 2, 3, 4, and it would look like 1, 2 up over here. 1, 2 up over here. So something like, that's a horrible graph. Something like that line would be this graph right here. But then again, I only want it to be true up until negative 3. So I'm going to erase this part right here. Okay? And do I put a solid dot on it or an open dot? I'm going to put an open dot because of that, there's no equal to sign over there. Now, if I'm dealing within the range of negative 3 and positive 2, I'm going to deal with a parabola that is shifted down 2. So I've got my regular parabola, shift that sucker down 2. It probably looks something like this. I'll be honest with you, this might be an ugly graph, but it's not that bad. And this parabola is equal to on that side, so maybe a solid dot right here. Erase that part right there. And then this thing finishes off over here. An open dot right there. And then it's equal to x equals 3, or y equals 3. So no matter what the x value is, y is equal to 3, if I'm talking about this range over here. So at x equals 5, y equals 3. So it's 1, 2, 3 here. At x equals 4, y equals 3. So it's just constant 3 all the way across the board. And there's an open dot right there. That's what I would guess the graph looks like. Because it's kind of got all of these 3 different aspects to it. Does that make sense to you? And I'm not even asking you to graph hard things. I'm asking you to graph a line, a parabola, and a horizontal line. That's cool, Cougar. All right. I'm I'm erasing. I will move on. Alright, let's try this puppy on for size. Give me a second. I'm going